All right, let's dive in. Today, we're going to follow a single grain of sand on this absolutely epic journey. We're talking from its violent birth on a mountaintop all the way to its final resting place where it gets transformed into solid rock. We're about to uncover an incredible story, literally written in stone.
Seriously, what if you could just pick up a rock and read its past? See the ancient river that carried it, the desert it was buried in, or the ocean it once called home. Well, guess what? You can. Because every single sedimentary rock is basically a time capsule, a physical record of Earth's history.
So, where does a story like this even begin? Well, it all starts with the destruction of another rock. But this isn't an ending, not at all. It's actually the creation of something new, the raw material for our story, which we call sediment. Now, the process that kicks everything off is called weathering. You can think of it as Earth's own recycling program. It's this constant, relentless breakdown of mountains, cliffs, and boulders into smaller and smaller pieces. And if you think this process is slow, well, over millions of years, weathering helped carve the Grand Canyon. Without it, there would be no sand, no soil, no sedimentary rocks, nothing.
Weathering pretty much comes in two main flavors. On one hand, you've got physical weathering. Let's call it the hammer. It's just brute force, smashing rock into smaller bits, kind of like when ice freezes in a crack and splits a boulder right in two. But then you have chemical weathering, the dissolver. This is where water and air actually change the rock's chemistry, weakening it from the inside out.
Okay, so once our little grain of sand is broken free, it doesn't just sit there. Nope, its great migration begins. And this is the part of the story where our main character gets shaped, quite literally, by its travels.
So right after it's been chipped off its parent rock, our grain is all rough and angular. Then it gets picked up by one of nature's massive transportation systems, maybe a rushing river, a powerful gust of wind, or even a slow-moving glacier. This is the start of a journey that could last for thousands of miles and, believe it or not, millions of years.
And a journey like that has a huge effect. It's just like a piece of glass getting tumbled by waves on a beach, right? All that bumping and grinding wears down the sharp edges. The farther a grain of sand travels, the smoother and more rounded it becomes. This simple little detail is a key clue for geologists. It lets them figure out just how far that sediment has traveled from its home.
And it's not just about shape, it's also about the company it keeps. See, when a river is absolutely raging, it can carry everything, boulders, pebbles, fine silt, the whole shebang. But as it slows down, it starts dropping the heaviest stuff first. So over long distances, this process sorts the sediments by size. A poorly sorted jumble of rocks means it was a short, chaotic trip. But a well-sorted deposit, like a fine, sandy beach, that tells you those grains have traveled far and been carefully filtered by wind or water.
Sooner or later, every journey has to come to an end. For sediments, this is a process we call deposition, where they finally come to rest. And let me tell you, the place where they stop has a huge impact on the final chapter of their story.
First up, we've got the continental, or land-based destinations. A grain might settle in the super still waters of a quiet lake, creating these fine layers of mudstone. Or it could be dumped by a flash flood in a rocky alluvial fan at the base of a mountain. Maybe it piles up in a vast desert dune field, destined to become a future sandstone. Or it could just be unceremoniously dropped by a melting glacier. Each and every one of those locations leaves its own unique signature.
Then you've got the really dynamic shoreline environments, where the land meets the sea. Here, sediments can build up in these massive deltas at the mouth of a river. Or they can be constantly washed by waves on a beach, creating that clean, perfectly sorted sand. Or they might settle in muddy tidal flats that get exposed between high and low tide. Can you just picture the totally different types of rock these places would make?
And finally, we get to the marine environments. This is the ultimate destination for most of the world's sediment. We're talking about the shallow continental shelf, the incredibly deep seafloor, and even those vibrant organic reefs built by living creatures. The vast, vast majority of sedimentary rock on this planet forms in these underwater realms.
Okay, so our grain of sand has been created, it's been transported, and it's been deposited. It's now resting with billions and billions of other grains. But here's the thing, it's not a rock yet. For that to happen, it has to go under some serious pressure.
The scientific term for this whole transformation is diagenesis. It's basically a catch-all word for everything that happens after deposition, as that loose sediment gets buried deeper and deeper, turning it from just a pile of sand into a solid sandstone.
So, how does this actually work? Well, it's a pretty straightforward two-step process. First up is compaction. As more and more sediment piles on top, the sheer weight squeezes the grains together, forcing out all the water that's between them. Then comes cementation. Minerals that were dissolved in the leftover groundwater act like a natural glue. They crystallize in those tiny spaces and cement the individual grains into a single, solid rock.
And now, we get to the payoff. Our grain of sand is officially locked into a rock. Its journey is over, but its story is now permanently recorded. All we have to do is learn how to read it.
We read these stories through things called sedimentary structures. Now, these aren't the grains themselves, but bigger features preserved in the rock that act like words and sentences in a book. They're literally fossils of the physical environment, ripples from an ancient current, cracks from a dried-out mudflat, all frozen in time.
Just look at the kinds of clues we can find. You can see these distinct layers, or what we call bedding, which show how sediment was laid down over time. And look, on the top surface, you can actually see ripple marks, which might tell us about ancient waves. Other rocks might show cross-bedding, revealing the direction of ancient currents, or even bioturbation, those little tunnels and burrows left behind by creatures that lived in the sediment. It's amazing.
Ultimately, it all boils down to this one simple but really powerful idea. The rock itself is a direct piece of evidence. By studying its grains, its chemistry, and all those structures, we can reconstruct the world in which it formed with absolutely incredible detail.
So, I'll leave you with this little puzzle. Imagine you find a piece of sandstone right in the middle of a desert, but its grains are super smooth, they're all rounded, and they're all pretty much the same size. Based on everything we've just talked about, what story could that rock tell you about a long-lost ocean that might have existed right where that dry land is today? The clues are all there, written in stone, just waiting for us to read them.